Hi, for my power electronics subject, this is summative assessment 4. In this summative assessment, we're given a problem to solve mathematically and using PSPICE application. The problem is a single-phase bridge rectifier has an RL load with um, a resistor of 10 ohms and an inductor of 25 millihenries. The AC source is Vs equals 170 sine 377 volts. Determine the average and RMS currents in the load and in each diode. So this is my summative assessment 4. This is the mathematical solution. So as you can see here, in my mathematical solution, this is the average and RMS current in the load. These are the values, given values for the solution. And we have to find the average current and RMS current in the load. This is for the average output voltage. It's 108.2254. Average output current is 10.888225 and amplitude of AC voltage at N2 22.1503 volts. And in N4, it's 14.4300 volts. Next, if we are to get the amplitudes of the first two AC current terms in current Fourier at N2, again, let's just substitute the 2 to the formula. Um, we're going to get 3.3813 amps. And for substituting it to the formula is 0.37 amperes. Next, for the RMS load current, um, substituting the values, we're going to get 11.0865 amperes. The average output current in the load is 10.8225 amps there, and the RMS current in the load is 11.0865 amperes. Those are the important values that we need to take note of, and the average and RMS current per diode. Let's head on here as the second part of our problem. That's the formula. And for the solution, the average current per diode, substituting the formula here, FO over 2 is 5.4116 amperes, and substituting the value of the average current here for the formula for the RMS current, value is 7.8393 amperes. This is the summary. Next, for the computation using the application, we're going to get the values. So here, as we can see here, that's the circuit. So upon this is the simulation settings. Upon clicking the edit simulation, I've put runtime to 33.37 milliseconds and start saving time to 16.67 milliseconds. So running PSpice. Here, what we're going to do is add the trace for the average current in the load and the RMS current in the load. So average current in IR1, this is the waveform. And let's add another one. The RMS current for the load is RMS and IR1 too. So here are the waveforms for the average and RMS load current in the load. Getting the values at the very end of the waveform is the average. So as we can see here, the average current is 10.348 and the RMS is 10.615. These are the measured values. Next part of the experiment is still the same, but we're going to get their results per diode. So let's just delete this and add a trace that will show the waveforms and their average and RMS load currents in per diode. So here, let's click on AVG and select on IR1 over 2. there. Let me just delete this. And of course, the RMS to get the formula for the diode, per diode. Let's click on that and over square root of 2. So we will just type to get the square root of 2 SQR times 2. Oops, I forgot to put the parenthesis in the 2. It's important to place that there and okay. And then next is, of course, cursor on to measure the average and RMS load current values per diode. At the very end of the waveform, as you can see, the value for the average um, current per diode is 5.1739 here. And for the RMS current per diode is 7.5081. So here, as you can see, I've just summarized the results that we've obtained earlier. So these are the waveforms, and these are the values. And here, uh, we could see that these values are close to our computed values. Here in the comparison of the computed and measured average load current and RMS load current per diode values, we can see the computed value of 5.4116 and the measured value from PSpice is 5.1739, which is very close. And for the RMS current, 5.5061 and 7.8. So from the mathematical solution earlier, we observed that we got the um, values for the harmonic number 2 and n. So here, we're going to use that. We're going to get the average load current and RMS load current for D2 and D4. That stands for the N2 and N4. So here, the average load current, we can observe that for D2 and D4, N2 and N4, they have the same, almost the same average load current. And now let's check for the RMS. If we are to click on RMS, for the D2 there, for diode 2, and the RMS again for um, D4, we can observe that they also have the same values here. So let's check what exactly are those values. So of course, cursor on, and let's just place the cursors at the very end of each waveforms to observe the different values and to observe how close they are to each other. So here, if we are to check on the values, we can observe that um, the average load current for D2 and D4 are almost the same with 5.1794 and 5.1718. And for the RMS load current for D2 and D4, they are almost the same with 7.5092 and 7.5047. So here are the summary of the results that we obtained, the average waveforms for RMS and uh, for the average load current and RMS load current, their values, and this is the comparison table. So as you can observe here, the computed value and the measured value for the average load current are very close to each other with 5.4116 for computed, and for D2 measured is 5.1794 and measured for D4 is 5.1718, and for the RMS current per diode computed 7.8393 for D2 and D4, and for from the simulation, D2 is 7.5099 and D4 is 7.5044, which are very close to the computed value.